There is a river in the American West that has been carving its way through rock for 6 million years. It has cut a canyon a mile deep and 200 miles long. It has flooded entire valley for 10,000 years. Entire civilizations rose and fell trying to live beside it. Every one of them eventually lost. This is the Colorado River, and in 1931, the United States government decided to stop it. What followed was one of the most audacious engineering projects in the history of human civilization. A concrete wall 726 feet tall, built in the middle of one of the most hostile deserts on Earth by men working in temperatures that reached 140 degrees Fahrenheit for wages of 50 cents an hour. It would be built in 5 years, ahead of schedule and under budget. It would be built at the cost of more than 100 lives, and when it was finished, it would be the largest dam on Earth, a structure so massive it would hold back an entire inland sea. This is the story of Hoover Dam, and it starts, as so many American stories do, with a disaster. The problem with the Colorado. For most of its history, the Colorado River was genuinely unpredictable to a dangerous degree. In the spring, fed by snowmelt from the Rocky Mountains, it would swell and rampage across the desert southwest, flooding the farmland that settlers in California and Arizona had worked for years to build. In the summer and fall, it would shrink to almost nothing, leaving those same farmers with no water at all. The worst single example came in 1905. An irrigation canal feeding California's Imperial Valley, one of the most fertile farming regions in the country, developed a break in its headgates. The entire flow of the Colorado River redirected itself into the valley. For 2 full years, the river poured into the Imperial Valley with no way to stop it. It created a lake 45 miles long, drowned hundreds of farms and 2 entire towns, and caused tens of millions of dollars in damage before engineers finally managed to plug the breach. That lake still exists today. It's called the Salton Sea. For the farmers, the city planners, and the engineers of the American West, the message was clear. The Colorado River was not a resource. It was a threat, and the only way to make it useful was to completely overpower it. The solution everyone eventually agreed on was a dam. Not a small dam, not a modest dam, but a dam so enormous that it would tame the entire river in a single structure. A dam in Black Canyon, on the border between Nevada and Arizona, that would create the largest reservoir ever built in human history and generate enough hydroelectric power to light the cities of the Southwest for generations. The question was, who on earth was going to build it? The contract of the century. By 1930, the federal government had finalized the design and put the Hoover Dam project out for bid. The specifications were extraordinary. The winning contractor would need to divert the entire Colorado River around the construction site, excavate millions of cubic yards of rock from a narrow desert canyon, pour 3.25 million cubic yards of concrete, more concrete than had been used in all the federal projects of the previous decade combined, and complete the whole thing within 7 years. Failure to meet the deadline would result in crippling financial penalties. The performance bond alone, the financial guarantee required just to submit a bid, was $5 million. In 1931, that's the equivalent of nearly $100 million today. It was a number so large that no single construction company in America could put it up. The risk was simply too enormous for any one firm to absorb alone. So instead, 6 of the most powerful construction companies in the American West formed a joint venture. They called themselves 6 Companies Incorporated. Among them were men who would go on to shape the physical landscape of 20th century America. Henry Kaiser, who would later build the Liberty ships that helped win World War II. Warren Bechtel, founder of what would become the Bechtel Corporation, one of the largest engineering firms in the world, and a group of other contractors with the collective experience, capital, and sheer nerve to attempt something that had never been done before. Their bid came in at $48.9 million, just $24,000 under the government's own confidential estimate. Some historians believe this was no coincidence. Whatever the case, 6 companies won the contract in March 1931. Construction would begin immediately. Boulder City, a town built from nothing. Before a single shovel broke ground on the dam itself, 6 companies had to solve a problem that doesn't get nearly enough attention. Where were thousands of construction workers going to live? Black Canyon is in the middle of the Mojave Desert, miles from the nearest town of any size. Las Vegas in 1931 was a small railroad stop of about 5,000 people. nowhere near capable of housing the workforce the project required. So the Bureau of Reclamation built an entirely new town from scratch, Boulder City, Nevada. It had dormitories, a mess hall capable of feeding 1,500 men at a single sitting, a hospital, a school, and a company store. Alcohol was prohibited. So was gambling. It was a company town in the most literal sense, and the workers were governed by 6 companies' rules around the clock. They didn't always love it, but Boulder City gave them something the surrounding desert could not: shelter, food, and community. And in the depths of the Depression, with unemployment at 25% nationwide, even a company town was better than the alternative. When applications opened, over 100,000 men applied for fewer than 5,000 jobs. The tunnel men. Before any concrete could be poured for the dam itself, engineers faced what was perhaps the single most technically challenging task of the entire project. They had to move the Colorado River out of the way. The plan was to drill 4 diversion tunnels through the canyon walls, 2 on the Nevada side, 2 on the Arizona side, each one 56 feet in diameter and roughly 4,000 feet long. The river would be funneled through these tunnels while the main dam site was excavated and built dry. When construction was complete, the tunnels would be sealed and the river returned to its original channel, now blocked by the dam. Each tunnel was large enough to drive 2 lanes of traffic through side by side. Drilling them required removing millions of tons of solid volcanic rock using dynamite and pneumatic drills, with workers suspended on wooden platforms called jumbo rigs, massive multi-level scaffolds mounted on trucks that could be driven up to the tunnel face. Crews worked in 3 shifts around the clock, 7 days a week, with a new blast cycle completing roughly every 4 hours. The work was brutally hot. The volcanic rock in Black Canyon absorbed and radiated heat like an oven. Temperatures inside the tunnels regularly exceeded 130 degrees Fahrenheit. Workers stripped down to as little as possible and drank water constantly. Heat exhaustion was an everyday occurrence, and the air quality was catastrophic, thick with silica dust from the drilling, a fine powder that coated the lungs and caused a fatal disease called silicosis. 6 companies officially classified many silicosis deaths as pneumonia to avoid liability, a fact that would later spark a landmark lawsuit from workers and their families. It is one of the darker chapters in the dam's history. Despite the conditions, the 4 diversion tunnels were completed in just over a year. In November 1932, cofferdams, temporary earthen walls, were built upstream and downstream of the dam site, and the Colorado River was redirected through the tunnels. For the first time in geological memory, the bottom of Black Canyon was dry. The construction of the dam itself could begin, excavating the foundation. With the river out of the way, engineers turned to the canyon floor. Before any concrete could be placed, every inch of loose, weathered rock and silt had to be removed down to solid bedrock. This process required removing another 1.5 million cubic yards of material from the canyon floor and walls using a combination of dynamite blasting, steam shovels, and an army of workers with jackhammers. Workers were also deployed on the canyon walls above the dam site in one of the most harrowing jobs of the entire project: high scalers. These men dangled on ropes from the canyon rim, hundreds of feet in the air, chipping away loose rock that could fall and kill workers below. They worked with jackhammers, crowbars, and dynamite, swinging on their ropes to reach the rock face while active construction proceeded directly beneath them. They became something of legends, known for their daring and for occasionally diving off the canyon walls into the Colorado River on their lunch breaks. A wall of ice water. Once the canyon floor was cleaned to solid bedrock, the real construction began, pouring 3.25 million cubic yards of concrete. And here, the engineers ran into a problem that no one in the history of construction had ever faced at this scale before. Concrete generates heat as it cures. This is a basic chemical fact. The process of concrete hardening is an exothermic reaction, meaning it releases energy in the form of heat. For a small concrete pour, this is not a problem. The heat dissipates naturally into the surrounding air and ground over a matter of days. But for Hoover Dam, engineers calculated that if they poured all 3.25 million cubic yards of concrete as a single monolithic mass, the heat generated by curing would be so enormous that it would take approximately 125 years to dissipate naturally. The concrete would crack, shrink unevenly, and potentially fail entirely. The dam would destroy itself from the inside before it was ever finished. The solution was a feat of engineering ingenuity. Rather than pouring the dam as one solid mass, engineers designed it as a mosaic of interlocking concrete columns, over 200 separate columns, each poured in blocks no more than 5 feet tall at a time, with gaps left between them. Each column was allowed to cool before the next block was poured on top. And running through every block, like a system of artificial veins, was a network of 1-inch steel pipes through which workers pumped ice-cold water directly from a refrigeration plant built on site. The refrigeration plant consumed as much electricity as a small city. Millions of gallons of ice water circulated through the dam continuously, drawing heat out of the curing concrete and carrying it away. When each column had cooled to a stable temperature, the cooling pipes were grouted full of concrete, and the gaps between columns were filled with grout under pressure, locking the entire structure together into a single unified mass. It worked. The concrete cured without catastrophic cracking. The dam held, but it had required inventing, essentially from scratch, a method of large-scale concrete temperature management that had never been attempted before and has informed large dam construction ever since. The scale of the pour. The scale of the concrete pour is almost impossible to fully comprehend. At peak production, the project was placing nearly 10,000 cubic yards per day, delivered by an overhead cableway system that carried 8 cubic yard buckets of wet concrete from the mixing plants on the canyon rim down to exact positions on the canyon floor. The cableway spanned the full width of Black Canyon and could position a loaded bucket with an accuracy of inches. Nothing like it had been operated at this scale before. The concrete was mixed in batching plants built specifically for this project, facilities capable of producing wet concrete at a rate and volume never attempted before. Aggregate mined from canyon deposits upstream was screened, washed, and graded into precise size categories before entering the mixers. Quality control was strict, every batch was tested, and any that failed specification was rejected. The entire operation ran 24 hours a day, 7 days a week, for 4 consecutive years. An industrial production line in the middle of the desert, run almost entirely by hand. Life in the canyon. To understand what it meant to work on Hoover Dam, you have to understand the world these men came from. It was 1931. The Great Depression had been grinding America down for nearly 2 years. In cities across the country, men who had held steady jobs for decades stood in breadlines. Families lost their homes. Farms were foreclosed. The national unemployment rate would peak at around 25%. Against that backdrop, the Hoover Dam project was not just a construction job. It was a lifeline. Men came from everywhere. Displaced farmers, laid-off factory workers, veterans with families to feed and no other options. They worked in canvas tents and wooden barracks in 110-degree heat, and they were grateful for it. The work itself was relentless. 6 companies operated 3 shifts a day, every day of the year. Workers on the dam face labored in open canyon heat that reflected off concrete and rock walls until the air shimmered. Workers in the tunnels dealt with darkness, dynamite fumes, and temperatures that soaked a man through within minutes of starting his shift. The mess hall cycled through thousands of workers at all hours, and a man who missed his window went hungry until the next sitting. Pay ranged from 50 cents an hour for common laborers to $1.25 for skilled tradesmen. By Depression standards, this was reasonable money. By any other standard, it was a brutal bargain. The dead. The official death toll for Hoover Dam construction is 96 industrial fatalities. These are the workers who died from falls, equipment accidents, blasting mishaps, and drowning during the construction period. The first official fatality was J.G. Tierney, a surveyor who drowned in the Colorado River on December 20, 1922, while searching for an ideal dam location. His son Patrick Tierney became the last official fatality, dying in a fall from an intake tower on December 20, 1935, exactly 13 years to the day after his father. But the true death toll is almost certainly higher. An unknown number of workers died from heat stroke in the canyon during the brutal summers, and 6 companies systematically classified many of these deaths as pneumonia or other causes to avoid liability. The silicosis deaths, workers whose lungs had been destroyed by years of breathing fine silica dust in the tunnels, unfolded slowly, often appearing years after workers had left the project. Estimates of the total silicosis death toll from Hoover Dam workers range into the hundreds. There was also the matter of the workers' families. Some had followed their men to Nevada and were living in makeshift camps outside Boulder City, settlements of tents and cardboard shacks that workers called Ragtown, sitting on the riverbank with no running water and no sanitation. In the summer of 1931, a heat wave killed an unknown number of people in these camps, including children. None of these deaths appeared in any official tally. The men who survived carried it with them for the rest of their lives: the heat, the noise, the dust, and the quieter knowledge of what it had cost. Most never talked about it much. You did the work, you came home, you didn't make a fuss. Ahead of schedule. In September 1935, President Franklin D. Roosevelt traveled to Black Canyon to dedicate Hoover Dam. The project had been completed 2 years ahead of schedule, a fact that 6 companies and the Bureau of Reclamation were justifiably proud of, and that Roosevelt used as a symbol of American resilience in a country that desperately needed one. Roosevelt stood on the dam crest in front of thousands and delivered a speech framing the dam as proof that Americans could tackle any challenge, that the West, now tamed and powered, could become the engine of new American prosperity. Newsreel cameras rolled and the images went out across the country and the world. It's worth pausing here to appreciate what had actually been accomplished. In 5 years, crews had drilled 4 tunnels each, the size of a subway line, through solid volcanic rock. They had excavated 1.5 million cubic yards of canyon floor. They had invented concrete cooling technology on the fly. They had operated a 24-hour industrial production line in the Mojave Desert for 4 consecutive years. They had poured enough concrete to build a 2-lane highway from San Francisco to New York City. And they had built a wall of concrete 726 feet tall that was, at the time of its completion, the tallest dam in the world. The final cost was $49 million, fractionally over the original bid, and well under the government's own estimate. In an era of Depression-era cost overruns and government spending scandals, this was remarkable. What the dam did, Hoover Dam changed the American West in ways that are almost impossible to fully enumerate. The most immediate effect was flood control. The catastrophic flooding that had plagued the Imperial Valley and the lower Colorado Basin for decades essentially ended. Lake Mead, the reservoir created by the dam, stretching 112 miles upstream through the desert, could absorb even the most extreme spring runoffs and release water in a controlled, predictable flow that farmers and city planners could actually rely on. The hydroelectric power output was transformational. The dam's 17 generators began producing electricity almost immediately after completion, supplying power to Los Angeles, Las Vegas, Phoenix, and the broader Southwest. It was this electricity that made possible the explosive growth of Las Vegas as a city, powered the California factories and shipyards of World War II, and electrified rural areas of Nevada and Arizona that had never had reliable power before. Lake Mead itself became the water supply for a region that would eventually grow to tens of millions of people. The cities of Las Vegas, Phoenix, Tucson, and large parts of Southern California would be literally impossible without the water stored behind Hoover Dam. Every time someone turns on a tap or fills a swimming pool in Las Vegas, they are drawing on a reservoir that exists because in 1931, 6 construction companies decided to move a river. Hoover Dam is now nearly 90 years old, and the Colorado River is in crisis. Decades of drought, accelerating with climate change, have drained Lake Mead to historic lows. The dam's power output has been significantly reduced, and federal authorities have imposed water use restrictions on dependent states for the first time in the dam's history. The white bathtub ring on the canyon walls, marking where the waterline used to stand, has become one of the most striking visual symbols of the American West's water emergency. And yet the dam itself stands exactly as it was built. The concrete shows no meaningful deterioration. The generators still turn. The water still flows through the penstocks and into the irrigation canals and cities of the Southwest. It is doing, nearly 90 years later, exactly what it was designed to do. Somewhere in the construction records, in the payroll ledgers, and the safety reports and the letters that workers sent home to their families are the individual stories of the men who built it, the high scalers dangling on ropes, the tunnel men breathing silica dust in the dark, the concrete workers watching a bucket of wet concrete descend from the canyon rim on a cable thinking, "We are building something permanent, something that will outlast us." They were right. The Colorado River still runs. The desert is still brutal, but in Black Canyon, on the border between Nevada and Arizona, there is a wall of concrete 726 feet tall that has been standing since 1935, and it will almost certainly be standing long after everyone alive today is gone. That is what they built, with 50-cent-an-hour wages, pneumatic drills, and ice water running through pipes in the concrete. In 5 years, during the Great Depression, in the middle of the Mojave Desert, there are no words for how extraordinary that is.